Hi everyone. So in this example problem, we are going to apply Rawls' theorem with this function, p of x equal to 7x cubed plus 91x squared plus 280x minus 4. And it says note that p of negative 8 equals p of negative 5 equals negative 4. So they were really nice here. They're kind of making it so that we don't have to do much checking of the criteria for Rawls' theorem because we have a polynomial, so we know that that polynomial is continuous over a closed interval from negative 8 to negative 5 and differentiable over the open interval from negative 8 to negative 5. And then they just told us that the endpoints of that closed interval have equal output values. So that means that Rawls' theorem is then telling us that there exists a C such that p prime of C is going to equal 0. So let's first find p prime of x. So using the power rule, we have 21x squared plus 182x plus 280. And therefore, there exists some C such that p prime of C, which is 21c squared plus 182c plus 280, is going to equal 0. So we want to factor this and solve for c. So we can factor out a common factor of 7 first, and we'll have 3c squared plus 26c plus 40. And if we factor this, we'll do a 3c and a c, and then we want to multiply to get 40, so let's put the 20 here and the 2 here. That'll give us a 20c and a 6c, which will give us 26c in the middle. And we've got this factored, which means that 3c plus 20 will equal 0, or c plus 2 will equal 0. Over here on the left, if we subtract the 20 and divide by 3, we'll have c equal to negative 20 over 3. And here we have c equal to negative 2. Now we have to be careful, and we want to make sure that we look at our interval. So our interval was from negative 8 to negative 5. So we want to double check to make sure both of these values are in the interval. So negative 20 over 3 is about negative 6.67, and that is in the interval. So this is one value for c. Over here, c equal to negative 2, that's not in our interval. So not in interval. And therefore, we're not going to include this in our answer, and our only answer is going to be this negative 20 over 3.